Good morning, pre-algebra. So as always, start now with a joke. What washes ashore on tiny beaches? What washes ashore on tiny beaches? Well, that could only be microwaves. Microwaves, yes, that's it. I am just so excited. I hope you are too to be back from a 3-day weekend. And we're just going to jump right into some new material. So this isn't all new. We have some familiar words, but we have a new word. So I am on page 311 of your pre-algebra book. Make sure that you turn there and follow along, or even take notes. I've noticed that some of you struggle kind of getting motivated, but as soon as this video is done, you got to tackle it and work hard. That's what we're really focusing on for these next couple months as we kind of finish out the school year. Working hard. So here's our new word. Our word is dilation. Dilation. And the definition, it says it either enlarges or reduces by the scale factor. So if you remember, a scale factor is a number. It could be a number like 2, it could be a number like 1/2, it could be any kind of number like that. Remember, it also could be put as a ratio. So you have 2 to 1, or they'll say 2 to 1. Finish the T. There we go. But most likely your scale factor, you'll see numbers like these, just normal numbers. Okay? So let's look at our first problem. The idea is that we are going to be given a figure, and we're talking about on our coordinate plane. So when I say coordinate plane, think your y-axis and your x-axis, and you start at 0, and these numbers are negative, and you got your x-coordinates, and then you have your y-coordinates. That's all important things that you will need to know. So unfortunately, I'm not prepared enough to put a graph on here and actually graph it, but I think you guys can be successful with that on your own. So let's take a look at our first problem. Example number 1 at the bottom of page 311. So it says a figure has vertices j, 2, 4, and it has k, 2, 6. We also have M, 8, 6. And finally, our fourth place is N with 8, 2. Okay? Graph the figure in the image of the polygon after a dilation with a factor of 1/2. So the first thing that you want to do is graph your figure. So you're going to need a graph paper. Make sure you grab that when the video is done. But you're going to graph your figure. Then you're going to do the dilation, which is taking in the scale factor. Now you're like, well, what do I do for that? You haven't told me yet. Well, I'm going to tell you now. So what you do with your scale factor is it's pretty easy. You just multiply your scale factor by your x-coordinate and your y-coordinate. So here's the example. Remember, our scale factor is 1/2. So we're going to do each coordinate at a time. So we're going to start with j. So we're going to do 2 times 1/2. And we also have a blob. Then we have 4 times 1/2. Easy as pie. All right? So our half would be our new coordinate. So let's put, what does it say? You want to do a J with a little apostrophe. That kind of shows that it's similar. So half of 2 is 1. And half of 4 is 2. So that would be our new coordinates for J1 or J apostrophe. Okay, then you would do that to all of them. So I'll just do one more for an example. So let's do M. M equals 8 times 1/2. And then we have 6 times 1/2. So we have M1 equals 4 is our x-coordinate, and 3 would be our y-coordinate. Okay, so that's all you're doing is you're multiplying your scale factor times your, well, times your coordinates. All right, so you can figure out the rest. All right, moving on. Next page. And we're going to skip 312. That's just some more practice. I feel like you can get the process. Really, you're just, again, multiplying the scale factor by each coordinate. And don't forget about the graphing. But now we're going to have to figure out, okay, well, what if they tell us to find the scale factor? So turn to page 313, and we'll do the example number 3. So it says a drawing of a school mascot is to be increased as shown at the right so it can be painted on the gymnasium doors. What is the scale factor of the dilation? So we're given two different images of the eagle, that must be some school's mascot, and we're trying to figure out that they want it to increase. So we're going from small to big. That's important. So we want to do the small to big. So we are first going to work with our large numbers. So if you see how they kind of color-coded it, that's really important. Make sure you're on this page. So it says, write a ratio comparing the lengths of the sides of the two images. Subtract the x-coordinates to find the lengths. So we are subtracting the x-coordinate from the large one to the small one. Or excuse me, we're doing the large one. So we have the length, we have the right side of it, the 9 red, minus the red 3, which is on the left side. So you're doing the x-coordinates of the bigger one subtracted by your, so you're doing the x-coordinates of the big ones, subtraction, and then you're doing the same thing with the smaller one, 3 minus 1. Okay, someone's pounding on the door. I gotta pause. Alright, now that we solved that problem, I'm back. So here what we're going to do. What we have to do is we're doing the length of dilation. So the new figure, that's what or the one that we want. So that's the one we're looking for. Divided by the length of the original. So our dilation is the big one, so we're looking at the big eagle. So the way that this is going to work is that we got to find the length. So the way we're going to find the length is by doing 9 minus 3. Now sometimes, well, 9 minus 3. Now the length of the original, we've got to do 3 minus 1. Oops, I'm just too quick. 3 minus 1. Alright, so we are left with 6 over 2, which equals 3. So our scale factor is 3. That's our final answer. So remember, we're doing the length of the dilation, which is the one we want to change, divided by the length of the original. So now sometimes they might not give you, they might just give you the lengths. So look at the number 3, guided practice, right underneath the eagles. So what it says Megan wants to reduce an 8 by 10 inch photo to a 2 by 2.5 inch photo. What is the scale factor? So here's where I have to think of paper. So when I think of paper, your normal paper that a worksheet is 8.5 by 11. So we have our worksheet, which is something like this, right? So this is the 8.5, and this is the 11. So if we're talking about this, we're talking about, instead of 8.5 and 11, we're talking about 8 by 10. So we're going from a bigger one, 8 inch by 10 inch, to a smaller. But the length is still longer, except it's 2.5 by 2. So sometimes you may have to draw it. That just helps visually for me. So then we look at our length. So what's our original? Original is this one. So that's got to be on the bottom. So we have our length is 8. We don't have to do subtraction because we already know it. We didn't know the length. For the eagle, we had to do subtraction to find the length. So we already know that length. Now what's the length of this one? So 2. That's the one we want. That's our dilation. So we put the dilation on the top. Original and dilation. Alright, so simplify that down, and our scale factor is 1/4. So remember, the important thing is dilation divided by original. The other thing is write it out. You're talking about the length. Make sure you're choosing the same sides. You would get messed up answers if you did 10 and 2, because they are different sides. They don't go together. Now you could have done 10 and 2.5. That still would give you the same answer. But make sure you choose the same sides if they give you the lengths already. But if you're talking about the figure, like with the eagle, you might have to subtract to find the length. Alright, go ahead and work on your assignment, and I will see you in real life if you need help.